Hi, my name is Kevin Hand, coming from Fort Worth, Texas at Dynocom headquarters. This video today is going to get you acquainted with your new dyno purchase, and we're going to go over some of the basics that involves with your dyno setup. First thing we're going to go over is what comes with your dyno and basic strapping in order to keep you safe while using your new tool. Also, we're going to go through the multiple types of tests that you could do with your dyno, which include inertia only. You have eddy-brake, you have speedometer, you have engine power, you have ramp test. There's tons of tests that you could run with your new dyno. We're going to go through each one fully so you fully understand how to perform these. Today we have a two-wheel drive 15,000 series in our dyno room and also a 5000 FX all-wheel drive. We're going to show you on both. Let's get to the dyno room. We're going to go over what comes with your dyno in this electronics box. Your dyno ships pre-tested with all the settings and everything on your USB security key. You have your Quantum install disk that's going to be put on your laptop for the dyno software. This is your DC box. This is the main brain of the system. It has buttons on it just like the handheld that we're going to show in a little bit. It basically can be used to control the dyno. Your optical sensor, which is used for your RPM pickup. Also comes with a piece of reflective tape. The tape is going to be used to get the signal into the dyno stack. Your magnetic base, which will be used to shoot the laser. Your power cord, shielded USB, the NTK sensor that ships with the Dynocom AFM2, your RPM box, which gets your signal from the laser to the DC box, your atmospheric module with the Ethernet cable that connects to it. This basically tells the dyno your weather, DC handheld, which is going to be used to do your runs, stop and go button. Everything that can be controlled for the dyno can be done from inside the car. All your cables, air fuel, DB9, DB25, and the RPM box. By now you have your dyno installed in your shop. We're going to go over a couple of key features of things that still need to be connected before you can start using your dyno. If your dyno is equipped with an eddy-brake, you're going to connect your pause sensor, which is the S-beam, on the other side of the dyno. DB25 cable, which connects the J box to the DC box, plugs underneath. You'll also notice right here we have the plate, which is your dyno's model and all the data for this particular model. This data is also on the USB security key for Quantum and holds all the data and hard codes it so your dyno's data cannot be manipulated. Your speed encoder, which tells the dyno its drum speed. Plugs are here. And at last, your air source for the drum, the brakes to slow the drum down. Now that we got the vehicle in the shop, we're going to go over some basic two-wheel drive dyno procedure. Anytime you're not going to be in the vehicle and setting up, always be sure to apply the emergency brake if it has one. This particular Dynocom 15,000 series install is above ground, which utilizes a 4-post lift. As an extra precaution, we're going to chock the front wheels when we're going up with the lift. shipped with high quality max straps and axle straps. We're going to go through a front tie down procedure and then move to the rear of the vehicle. As you can see, I've chalked my front wheels again. This is temporarily because we may have to move the vehicle on the position of the rear drum. What I do is I feed my axle strap through the suspension on the front. What you want to do is you want to look for a location that's around something sturdy. Every vehicle is going to be slightly different. Another trick you could do, what I like to do also, keep the axle strap already attached to the strap, so you're just feeding in one direction. On this particular GT500, we have an A-arm, and the steering shaft is right above it. We want to make sure we don't strap over the steering shaft, because when we apply pressure, we're going to bend something. You're going to leave the straps loose at first because we're going to make some adjustments. Before we move on to strapping the rear of this vehicle, another important note about front strapping. Turbo cars. Make sure your straps on externally wastegated vehicles are nowhere near the exhaust. You can and will melt a strap if the exhaust hits them and break a strap during a pull. So make sure you know where your straps are running on those types of vehicles. This particular vehicle, Mustang again, we're going to strap the rear. What we're going to do is we're going to take our axle straps. We're going to find something that is sturdy. Be aware of brake lines, rear brake cables, anything back there that shouldn't be strapped to. You just want to make sure you have a sturdy connection so when the force of the car is on there, nothing gets damaged, bent, hangs up a caliper, applies a parking brake when it shouldn't. All this stuff can and will affect the numbers on your dyno. Strapping is a very important procedure to go over and to do it very well for every car. On this Mustang, there's a parking brake cable that runs through the control arm. We make sure we run the axle strap in between the two so that when the straps are tight, it doesn't pull on it. Certain cars you'll have to either go to the axle itself or a control arm. Basically every vehicle you have to assess where is the best spot to strap to. So what we're going to do on this vehicle is we're going to do 2 forward parallel straps and 2 cross straps. That's if any of the straps should break, the car is still going to stay on the dyno. can see, I've left the straps a little loose. We're going to move on to positioning the car on the dyno. Right now the car was just backed up. We now have to let the car settle on the drum the correct way, which means unlocking the drum and driving the car very slowly to let the car settle on the back of the drum parallel to the drum itself. Now that we're going to be going to center the vehicle on the dyno, now's a good time to check your tire position and also check your tire pressure before you move on to final strapping. We always want the car on the dyno in 11 to 2 o'clock position on the drum with the tire with the center line. This particular car, we're pretty much on top of the drum, so we're pretty good. A little trick that you can do is, that's why I leave the straps loose and the chock's ready to move. You don't even have to get in the car and start the car to move it on the drum. You can literally cheat your chocks a little bit and say the car has to move a little bit forward on the drum, you pull up tighter on the front straps. If you need to go back on the drum, you pull back a little bit tighter on the rear straps, leave a little more slack in the fronts. You can get your position before you even move on to that. So now, since this car is ready, we're going to get in the car, unlock the drum, accelerate very slowly, basically roll the drum, let the car settle itself. Once that's done, we're going to final strap and get on to testing. Now we're going to start the vehicle, unlock the drum, drive the car very slowly, center the car. Once we're done, we're going to leave the drum unlocked because we're going to do our final strapping tight, and we're ready to test. I left the car in neutral. Drum is unlocked. It's centered. We're ready to go. Tighten the straps. Ready to make some pulls. I have my front straps equally tight. Now we're going to move to the back. Key thing to talk about is, you see online people with videos with dynos, cars moving on the dyno, straps are loose, looks cool for videos. If your car moves on the dyno, it's not safe. You should strap tight, make sure the car is secured. You don't want it moving around on the drum. For the back, we're going to strap the 2 parallel ones first, and then we're going to tighten the cross ones. Easy way to check your strap tightness is put your hands on it and feel how taut they feel. Adjust if necessary to make them equal. Also, while you're there, it's a good idea to take a peek, see if anything's hitting, rubbing. Exhaust. Some cars have exhaust that lies low. You're going to want to either move your straps if that is a case, or another trick is to cut silicone. High temp silicone, you can actually shield the straps so they don't melt. Now we're going to go over setting up the optical for RPM. Now that the car is strapped, we need a way to get RPM into the dyno. We use optical, I do personally, because it's not susceptible to RF noise or EMI. What it does is it uses a laser beam with optical tape, and this laser beam picks up the signal, which reports to the RPM box, which tells the computer your RPM. What I like to do is I always go for the crank on any vehicle I have. Me personally, I specialize in Ford and GM products. I devise ways to get the laser in a position to shoot the crank. Sometimes you have to move stuff, reposition. Other owners of the dyno have made clamps, little fixtures for their particular models that they're working on. The thing is, your results with this are accurate. Inductives can pick up noise, which will affect the results. Snapshot is a good tool, but it also has its drawbacks. If you want the utmost accuracy, optical is the way to go. So I'm going to run through a quick procedure on this GT500, how to set it up. Honestly, a lot of people complain that it takes too long, it's this, it's that. I can have this set up on a car in about 5 minutes. I'm going to do that right now. On this GT500, I'm going to remove the water bottle and move it to the side to get a direct shot at the crank. We have this plate that I made. I attach it to the computer bracket. Magnetic base goes right to it. Magnetic tape, we have a piece cut already. We're going to place it down on the crank. Thing to keep aware, your magnetic base, if you're high up on the stalk on it, you can and will get vibrations. What I tend to do is I try and keep it down as low as I can. Also, wherever you're mounting to, make sure it's sturdy. Any kind of dropout you get during a pull, most likely is because the optical moved. The size of your tape also plays a key thing. I tend to go a little bit bigger with the tape, so if it does vibrate, it still shoots the tape. Now that we have our plate mounted, we're going to position the laser beam, and we're going to place the tape down and show you how to shoot the signal. Now we've pre-cleaned the crank on this, on the balancer. We wiped it with brake clean. You're going to want to get into a habit of cleaning whatever you're going to stick the tape to. While it is sticky, it can and will come off with either cars that are oily or have dust or whatnot on it. Tape is placed. We're going to adjust the laser so it's shooting right on it, and start the car and check our signal. Now that we have our optical tape down on the crank, we're going to set up our run in Quantum. Just want to add another bit of information for people that absolutely cannot get a shot at the crank. In Quantum, we could set up ratios for pulleys. So you could take any pulley on this vehicle, put a piece of optical tape on, and in the software you can basically set your idle RPM if you know it's 650, 700. You could tell Quantum that it's at 700, click the button, and it will do the automatic calculation of what it's seeing at the laser and do the ratio. We have our air-fuel module plugged into the back of the car. By default, it is not on when you turn the dyno on. You're going to want to scroll either from the DC box with the up arrow until it says AF1 and AF2, and you can hit the plus sign to turn it on, which turns on the air-fuel module, or through the handheld, you can do the same thing and just hit the plus sign and it turns on the air-fuel. Now we're going to go to Create New Session. By default, it brings up a timestamp. I would get into the habit of being specific with the vehicles you're working on, especially if you want to go back and use them as resources for other vehicles that you're testing against. Customers come in and they want, they lose their dyno sheets and they want to have a printout. They come back months later. If you're labeling everything by timestamp, it's going to be hard to find. So basically, we're going to change this for this particular, since this is testing. We're going to call this run. Dynocom Quantum 101 GT500. If you had a work order for the vehicle, you can actually put the work order number in. VIN number. You can get the VIN numbers off the door jamb on certain vehicles, sometimes on the plate on the front. Again, get in the habit of maybe putting that information in. It's very good to use as a back resource. The customer sells a car. You don't know it's his car when it comes back to your shop possibly. You can look it up by VIN. You input it, you'll actually see that it's that vehicle you already did. Just for this test, we're going to just put GT500 as our VIN number. 2013. The make. If the make isn't listed, you can input it and it will save it. Me personally, I've had race cars that come to the shop that are either tube chassis or not even a brand. A dirt car, I can label that as dirt car. The software is fully customizable. So this is a Ford. It should have models already in there. We're going to scroll to GT500. In this, it only says Mustang. We can actually go in and add GT500 to be more specific. Now, the drop down for weight gives you 3 versions, basically what the vehicle is. 3,800, 4,000, and 4,200 based on the different miles of vehicle. You pick what fits this vehicle. This is a coupe, so it's going to be right around 4,000 pounds. More information you can add for the vehicle: number of cylinders, plug firing angle, type of fuel that it's running. This is supercharged, so we're only going to change a few of these. Red line, 6,500 on this vehicle. Don't want to go past that. Be aware of the vehicles you're working on also, that you don't overextend their hardware and have failures. You can set up your transmission gearing for reference. Now basically we're going to start our first run. What we're going to go to is new run. Now with the new run, you're going to have a bunch of things come up based on all the different tests which we're going to run through today. Right now we're going to do inertia only without the eddy brake on, using the optical. So it's going to be a gear roll-on, RO, which is roll power and torque test with or without load. We click on that, hit the next button. It's then going to ask you for your load settings. We're not going to use load, so we're going to do none. It's then going to ask you run engine RPM settings. You're going to have no pickup, ignition box, coil, spark plugs or injector, optical pickup, gear ratio, snapshot, or OBD2. Again, we have optical pickup on this vehicle. We're going to click optical. Hit next. It's then going to ask you optical pickup settings. We have a choice. Engine crankshaft, which is 1:1, which is what we are using right now. Engine camshaft, which technically on this vehicle should be a 0.5 ratio, but we can't shoot a camshaft on this. User-defined pulse ratio, which is going to be calculated when we switch and show you how to do it with the supercharger pulley instead of the crank. So right now we have one engine crankshaft 1:1. It's pretty simple. So basically we would hit next. We then can add notes for this test. Since this test is going to be inertia, we're going to do, just say this car vehicle came into your shop and it's new and you're just checking its baseline before you add parts. You could do baseline, inertia, or anything else you need to add as a special reminder of what this pull was. Gauge screen comes up, we're ready to make our pull. Alright, basically we have our run started on the dyno. The software is just waiting for us to start our run. We have our brake drum on right now. We're going to take the drum off. When we start our run, we're going to hit go. What you're going to want to do is go into a 1:1 gear or as close to 1:1 without going into an overdrive. On this particular car, this is going to be 4th gear is a 1:1. So I'm going to start the car, accelerate 1st, 2nd, 3rd, 4th gear, pick my RPM. I'm going to generally start this vehicle about 1800 RPM up until red line for our power test. Right now this vehicle's idling at about 950. It's actually coming down, so it's going to be probably about 800. You type in 800, hit calculate. As you can see, it says 2,000 RPM. That's not correct. That's actually what the supercharger pulley is spinning at. As you can see, we tested it. It's saying 790 RPM is what the car is actually idling at right now, based on the supercharger pulley. It calculated a 2.587 ratio. Now we can start our test. Now that we have our inertia pulls out of the way, we're going to show you how to apply load now. We're going to do two loaded pulls. One's going to be a standard static pull, which is a defined load on the drum. And then we're going to do an interpolated load, which is going to basically ramp the load up as the pull goes based on the power that this car makes. This GT500 makes about 550 at the tire. We'll be able to pull that load number from a drop-down menu. So we're going to start a new run again. Gear roll on. Now we have our choices again. We have none, which we already did our no load pulls. Static, dynamic. Dynamic can be changed in the car. We're not going to go over dynamic. It's more of a user-defined use. Most of the time you're going to be using static and interpolated load. So we're going to start with a static load. General rule of thumb, depending on the eddy-brake version that you have for your dyno, is going to be about 10% to 15% per 300, 400 horse. When you have a big drum dyno like this with a gear reduction that's not in your favor, we like to stick with about 10 to 15%. When you're on a small cradle dyno, that number is going to be far less because you have a mechanical advantage on a cradle dyno. So for this vehicle, we're going to do 15% on this next pull. So we're clicking our load up to 15%. The switch is switched in the back to turn the eddy brake on. We hit next. Our optical pickup. We're going to switch back to engine crankshaft, which is 1-to-1. Previously, we showed you how to do it off the supercharger pulley. We'll label this run. Static, eddy, test, 15%. All right, we're ready to make our pull. Before we showed you how to set RPM up based on optical, we're going to actually do, if you want to do snapshot, which is a fixed ratio. It takes a snapshot of the drum speed versus the gear ratio of the car. For automatics, we like to start the run at a higher RPM where the torque converter would be locked up, so there's no slip, which would impact your reading and your numbers. On a stick car, as in this GT500, it's a 6-speed. We're going to do 4th gear again, but we're going to hold the car at 2,000 RPM. We're going to hit the go button at 2,000 RPM. It's then going to lock that 2,000 RPM and do a calculation based on drum speed and the ratio of where the car is and come up with the actual RPM. For manual vehicles, it's very accurate, not as accurate on automatics with very loose stall converters. So to start that run, we're going to go new run again, gear roll on. We're going to stay with our 15% static load. We're going to, instead of optical pickup, we are now going to click snapshot. Hit next. It's going to ask you snapshot trigger RPM. Basically it's self-explanatory. It's already set at a predetermined 2,000. You could change that for whatever you want. Certain vehicles, you may want higher RPM. Guys that do higher RPM like Hondas and 8,000, 9,000 RPM engines, they actually will do a 4,000 or 4,500 start. For this particular car, we're just going to do 2,000. So there's a tab that says lock snapshot ratio for all runs. What that means is after you do your 2,000, you hit the go button, all the other runs that you do will already be figured out, and you don't have to do the start at 2,000 anymore. You can start at 3,000, you can start at 35, you can start at 1,500. Once it's locked, it's locked. snapshot run with 15% load, we're actually going to do a negative pull now. What a negative pull is it measures the parasitic losses in the drivetrain, fluids, gearing, tires, which will actually give you a good representation of at the motor power numbers. So to start that run, we go to new run, you click negative and it has an N next to it. Negative run measures parasitic drivetrain power losses. Our snapshot is already set up. Our ratio is already done, so we don't have to hit go at 2000 again. We're going to label this negative coast down. Now what I'm going to do is basically I'm going to take the vehicle up to about 5,500 RPM, just driving. I'm going to hit the go button, and I'm going to clutch in and put it in neutral and let the vehicle naturally coast down. Depending on how far you want to go, we're going to take it to about 35 miles an hour or about 2,000 RPMs in gear. All right, we're going to be making our negative test run, which is going to tell us what our drivetrain loss is and how it's going to be applied to our at the tire numbers to get a representation of what this car makes at the motor. What we're going to do is we're going to accelerate in fourth gear up to about 5,500 RPM. We're going to then put in neutral, hit the go button, and let the car naturally coast down to about 2,000 RPM, 35 mile an hour, and hit the go button again to collect that data. We just finished up the negative run test. Now we're going to show you the engine power test. What's cool about the engine power test, it does 2 tests in 1 pull. Basically what we're going to do is we're going to make our pull for power, and then at the top of the pull we're going to put the car in neutral and coast down. What the engine power test does is it records both those and then applies it into the chart so you have your at engine power. Our snapshot's already locked, so we don't even have to do that again either. We're going to conduct our engine power test now. Like the negative test, it's going to have a coast down built into it, but it's going to be all in one. Basically what we're going to do is we're going to accelerate a power pull, 4th gear, up to about 6,000 RPM, clutch in, neutral, and let it coast down naturally. Do not hit go until you coast down. I'm going to shoot for about 40 miles an hour and then stop the run. Now that we've completed our engine power test, we're going to go to a VRS test, which is a vehicle road simulation test. Basically now we go to new run, VRS, which is virtual road simulation, power torque measurement using vehicle dynamic settings. You have 3 choices on parameters. You have use vehicle parameters, which is provided by car magazines and whatnot. You have vehicle dynamic coefficients, which is provided by the EPA, which is the most accurate, and you also have power at 50. For this test, we're going to use vehicle dynamics. Now, the thing to note is we're going to be using the eddy-brake again for this. That's what the virtual road simulation is going to apply with the eddy-brake. A good procedure that we always do that we didn't mention earlier is always ground your vehicles when you're using the dyno. Basically what that does is it isolates ground loops because that stuff, the static electricity in the vehicle can backfeed, it can attack electronics, cause glitches and so on and so forth. So always keep good dyno preparation with grounding the vehicles to the dyno chassis. We're going to perform our VRS test, which is a virtual road simulation. It's going to basically use the coefficients of the vehicle and apply it to the pull with the eddy brake to extend the pull to better represent real road conditions. Alright, now that we've completed our VRS test, we're going to move on to our ramp test. What the ramp test does with the eddy brake is you're basically going to control the length of the pull based on either vehicle acceleration rate or time, duration. We're going to shoot for the pull to be about 10 seconds long. So how we do that is we go in, we're going to start new run, go down to PAU ramp. We have it set at 50 miles an hour. It's going to end at 100. Our test duration is 10 seconds. Acceleration rate is 5, which is basically 5 mile an hour per RPM. These are the default settings also. We're going to pre-test hold, which is going to hold the car at for a set time before it lets the pull start. We're going to have it hold for 5 seconds. So basically I'm going to start the pull right before 50 miles an hour. We're going to ease into the throttle. It's going to come up on 50. The eddy brake is going to energize, hold for 5 seconds, and then the pull will start. Moving on to our ramp test, we have it set for a 10-second duration, and we have a window of 50 to 100 miles an hour. I also have a preload of 5 seconds. So what we're going to do is we're going to start, hit go, before 50 miles an hour, ease into the throttle, let the dyno grab the car, and then full throttle, let the eddy brake hold, and then we'll release and do the pull. We just completed our ramp test. Now we're going to move on to our speedo test. What the speedo test is going to do is going to basically make sure that the calibration on the speedometer is correct versus what the drum saw during the test. So we go to New Run. We're going to go to Speedo, which is Vehicle Speedometer Measurement. Now the speedo parameters we have set here is 40 to 70 miles an hour. We're going to do a step of about 10 miles an hour per. You can actually user configure it to keep the test shorter. We're going to go speed step of 10. So technically we're going to go 40, 50, 60, 70. We're going to label this speed test. Now we're ready to do our test. Important thing to remember is we're not going to be hitting go on the keypad inside the car. It's basically going to walk us through. You're going to read the screen and it's going to tell you to get to your mile an hour, and once you have that on your speedo, you hit the check mark which says OK, and then you step up to your next speed, hold that, hit OK, and you're going to move all the steps up until what we have predetermined would be 70 miles an hour. And then we're going to get out and it will actually look at a report and it will tell you if it passes or fails based on what you said the vehicle was doing versus what the dyno was reading. Okay, now we're going to perform our speedo test. Like I previously stated, we're not going to be using the go button to enter. The go button is only going to be used to start the test and to end the test. In between, for all the measurements, we're going to be hitting the OK button with a green check mark. Alright, we just completed our speedo test. As you can see right here, we have a readout of our mile an hour that we were reporting, basically from the speedo on the vehicle. Now we're going to break down and look at it and see how it performed compared to what the dyno said. So what we will do, we're going to go to report. So we right click right on the report, print preview. We're going to zoom in. As you can see, for indicated speed 40, actual speed was 38.2, speed error was 1.7, it gives you a percentage, result pass. 50, reported 48, 1.2 off, 2% error, pass. 60, it was actually 59 miles an hour, 0.6% off, actually 0.6 speed, 1% off, pass. All of them passed from 40 to 70.
Our 5000FX is a mechanically linked dyno via Gates belt. In order to lock it, you must flip a pneumatic switch and apply the pneumatic brake, and you're good to go. Straight back. Gonna be a little bumpy going on this first one. Just straighten it out. Yeah, straighten it out now. More? Yeah, a little bit more. Good. My head? No, keep going. Now you are. Okay. What is this? Yeah.